Hi everyone. So we're going to continue with talking about your circles, and we're going to focus on some properties that we have with your arcs. We talked about your arcs a while back in regards to both measurement and length, and we're going to make more reference to the measurement aspect here to help us find some more properties within our circles. So let's think back to some properties with our circles. Here you have two central angles. One you have central angle CED and the other one BEA. And note that you have those two arcs, which are indicating that both of those are congruent. If we make reference to some properties within your circle, we have four radii, which we know are all congruent. But here's something that I really want you to focus on, and that's the two triangles. If you look at all the information that you have for those triangles, you basically have two congruent triangles by your SAS quality, based on the fact that both of those triangles are isosceles with the legs congruent, and the central angles are congruent as well. We also know that with that CP-CTC property, if you do have those congruent triangles, that you're also going to have all the corresponding parts congruent. So the two chords CD and also BA are both congruent. Now here's something that's really cool. Because of those central angles, remember when we talked about your measurement, if the angle measurement was, say, 30 degrees, that means that the arc, so for example CD, would also be 30 degrees. But because both of those two central angles are congruent, that means that arc BA would also be 30 degrees. So a couple of things are happening here. If the central angles are both congruent, then the chords CD and BA that are opposite those two will both be congruent, and also the arcs. So CD, that arc, and BA, that arc, are also congruent. So both the chords and also your arcs. And those properties can go backwards too. So if you have the arcs congruent, the angles are congruent, and so on. So let's take this problem for example. Note that in this question I have two congruent chords, both ST and RQ, and I'm given two arcs. ST is 4x and RQ is 3x plus 22. So going back to the previous slide, if the chords were congruent, that was because we had some congruent triangles, the central angles were congruent, so that means that the arcs are also going to be congruent as well too. So if we're thinking in terms of solving for your variable, we could do 4x equals your 3x plus 22. And of course solving using your algebra, minus your 3x on both sides, so that gives you an answer of x equals 22. So let's try this one. This picture goes back to a couple slides ago that looked very similar with those two congruent triangles. As we mentioned, anytime that you see those central angles congruent, both the chords opposite them and the arcs are always congruent. So with these two, you have y plus 13 for chord JK, and you have 2y plus 5 for chord HG. Since they're both opposite those two congruent central angles, we know that both of their measurements have to be the same. So if we were looking to solve for y on this question, we could do y plus 13 equals your 2y plus 5. So your solution for this one would be y equals 8. Alright, last one. This one starts to bring back some of our properties from regular polygons. So you have a regular pentagon here inside of a circle. They want to know what the measurement of each arc is that's cut off by the sides of the figure. So keep in mind what it means to be regular. Regular meaning that all of your sides have to be congruent. So essentially here your regular pentagon is giving you 5 congruent chords. So again, bringing this all together, if the angles are congruent, the chords are congruent, which means if the chord's congruent, your arcs are congruent as well too. So basically here what you have is you have 5 equal chords that are all opposite these congruent sides from your pentagon. So if they're all congruent, and they all have to total 360 degrees, if you wanted to find the measure of just one of them, take your total, 360, and divide by your 5 to get your solution. So each arc on this one would be a total of 72 degrees. So really, folks, that's it. If you have congruent central angles, the chords are going to be congruent that are opposite them, and so are the arcs as well. So use any of these properties to help you with solving your questions on your assignment today. Good luck!